Hello and welcome. My name is Xander. I will be your instructor through this tutorial. Now, this tutorial is actually part of a whole course which you can access the first stages for free here on YouTube. Now, in this tutorial, I might mention resources and other tutorials. Do check out the link in the video description, which will take you to the playlist, and also there will be a link to the resources so that you can access and follow along here on YouTube. Now, if you like this course, you found it useful, and you want to take that next step, you can find this course over at Udemy. All the links to the resources can be found in the video description. Now, don't forget, also subscribe to the channel for weekly promotions, discounts, and free course giveaways. If you have been watching step by step up until this point, we have now created all of the tables and relationships between our tables that we defined in the ERD diagram. We have already seen and applied different types of constraints within our tables. So, for example, unique constraints and foreign key constraints. So let's now take a look at check constraints in PostgreSQL. Now, a check constraint is a different type of constraint in a Postgres database, which will allow us to specify a condition or expression that must be true for each row in a table. This is where we can really get this granular control over the data being inserted into the database. We're going to use it to restrict the values that can be inserted or updated in a table column. This helps ensure that the data meets a very specific criteria that we may have. Now, a check constraint ensures that a value of a column satisfies a logical condition. So if the value does not meet this condition, PostgreSQL will reject the insert or update operation. Now, a check constraint can be applied to an individual column to enforce specific rules, or it can enforce a condition on multiple columns. So it's very flexible. You can use any valid SQL expression in a check constraint, and this can include comparisons, mathematical operations, logical conditions, and functions. I couldn't possibly cover every single option in this tutorial, but I wanted it to be an introduction so that you can then go ahead and explore further. If you take a look at the ERD diagram, on the right-hand side, there is the data dictionary, and below that, I've added some examples of constraints and triggers, which we will discuss later, that we can create for our category table. Now, some of these may not be valid at this point, but just to give you an idea. So here we have a check constraint, the first check constraint here, and we want to check to make sure that the name is not an empty string. Okay, so this is important, and this goes back to creating null values. So if you remember, we configured the name field to be not null. So we have to supply some sort of value here in the name field. Now, if we don't supply, when we insert data into this table, a name, then what's going to happen is that in this case, the database is going to tell us that there's an error and we have to supply something because it is not null. Now, the problem we have here, in actual fact, is that we can insert an empty string, which essentially is no data at all, an empty string. Now, that is problematic because that means that we can insert records at this moment in time and not actually supply anything in the name field still, even though we've set the null to false. So if we add a new record, try and establish this further. If we add a new record, imagine we add a name to the category. So let's just go for TV. That's absolutely fine. So if we inserted a new record into the category table with the name of TV, happy days, that would work okay. So if we didn't supply a name at all, then the database at the moment will not allow null values. So that would not work. However, if we added a new record into the category table and just supplied something like this, depending on where the data originates from to be inserted, then this is still empty. This is an empty string, but this will still be allowed to be entered into our table at this moment in time. And essentially, this is Nothing at all. So this is not necessarily going to be the best approach, or isn't necessarily going to be the most desirable action for data, because it will mean that this category that we've just added here doesn't technically have a name. It just has an empty string. So to prevent empty strings, we're going to create a check constraint to avoid that. So if someone does try to insert an empty string, then it's going to tell them they cannot insert that record until they actually add a valid name to that record. So let's give it a go and see if we can create this check constraint. So in actual fact, we've already learned how to alter the product. Oh, actually, we don't want product, we want category. Apologies. We've already learned how to alter the category table. Okay, so we need to alter category table. Now we have this sub element for us to further expand and add other instructions. So we add a new constraint. So that's what we've seen thus far. We add a constraint, very simple, same as what we've been doing previously, but we want to add now a check constraint. So we specify the check keyword, and now we can then specify the actual constraint. So what we're developing here is, we can call this the expression check, and then we're going to define something here in the parentheses. So we need to build a rule now. So we need to first of all supply the field that we want to apply this rule to. In this case, it's the name field of the category. And then we can use the right left chevron. So here, this is equal to the not equal operator in SQL. So this is the not equal operator in SQL. So this is going to ensure that whatever we pass next, that this field should not equal to this value whenever we insert or update this or an individual record. So we're simply just going to add the empty string here. So this is the value the column should not contain, an empty string. So let's go ahead and add that. And we've now altered the table. So let's now inspect the table. We can see that we have now created the check constraint. So we now have this section check constraints, and the check constraint is called what we supplied. And the check now is, it checks the name for the text, and it should not be equal to an empty string. Now we might like to supply that on all of the tables that have different string fields. So let's just go for a product here. So check product name. So you might like to add this on, like I said, any field where we have a string. So that's going to be another check, but this time on the product table. So we can add that to the product table. So product doesn't exist. It should be products. Made that mistake again. So let's pass that in. So we've now added a check constraint on the product table. So let's take a look at another example, the slug field. Right, so let me quickly, briefly explain this slug field in a little bit more detail. Let's go back to here. Right, so what's happening here? Imagine this is your browser. You've got the URL. So you've got HTTP, www, and then your website name. Let's call this products.com. Okay, so typically when you go to some sort of e-commerce website, you go and find the product. So let's go for product. The link, the URL goes to product, and then maybe the name of the product. Okay, so this is the URL, which is going to take you to this particular product. Right. So how does the system know to show this particular product? Well, in this URL, there's some specific information. That's the name and maybe this sub element here. Let's just focus in on the name. Right, so this name here, we can potentially use this information to query the database and extract that information from the database so that we can make it appear here on the screen to the user. Now, we can refer to this as the slug. Okay, so this name, it might be a multi-name. So it might be name dash something dash something. So the name might have multiple components. But what's important is that this name is URL friendly, that it uses characters and a structure which is compatible to be used in the URL. So this is what I call a slug. a name or a string which is compatible to be used in a slug that we can use to maybe identify a product. Now, because I know that the slug, this name in this case, must follow a basic set of rules so that this string can be used in a URL, I want to make sure that when I insert this data in the database, that it is in the right format. So here we're going to build a check constraint, which is going to check to ensure that the slug, the string that we're passing and saving into the database for that row or record, actually meets the criteria, is compatible for a URL. So it should be lowercase, it shouldn't include empty strings, and it should only include, say, letters A to Z, 0 to 9, and a dash. So let's go ahead and add a new check constraint. I've called this check category slug format. So within our check expression, we can use a regular expression language, or regex. So what we're going to do here is do exactly that. So we're going to specify the field as per normal, and then we're going to use the title. So because we're going to be using regular expression matching, we're going to use the title. If I can find it on my keyboard. It's not working. Okay, so title, and then we are going to denote the fact we want to start our regular expression, and we're going to do that with the top hat. Okay, so this asserts the start of the string. It means that the matching must start at the very beginning of the string. And then we're going to use some brackets and define now the characters that will be allowed to be stored in this field. So A to Z, 0 to 9. And then in addition to that, we're going to also allow the dash, because in the URL, any words can be separated by dashes. It can't be spaces. Okay, then we specify plus, which denotes that one or more characters matching the previous character class, in this case A to Z, 0 to 9, or dash, must be present. So the slug must have at least one character, okay, that satisfies this pattern. And then we can go ahead and use the dollar to finish. So this denotes the fact that this must match, or a match must be made or must occur until the very end of the string that we're passing into this slug field. Right, let's give this a go. Let's alter this table. And we go ahead and see if we can add the constraint. And the product doesn't exist because I've added products again. Apologies. So let's see if we can add the constraint now. And then we'll go ahead and inspect. Okay, so there's our check constraint in place. So whenever we now try to insert into the products table, we need to make sure that when we enter anything in the slug, that it must follow this pattern. It must include only letters A to Z, 0 to 9, or a dash. So there we have some examples of using a check constraint in PostgreSQL to enforce rules on the data that can be stored in the table. So this helps to ensure integrity, data integrity and validity of our data, restricting the values that can be inserted or updated in a specific column.